Okay, today we're going to be starting your homework over 3.5 worksheet 1, which is over interest, isotopes, populations, and application problems. And the reason why I'm starting your homework with you, and I'm using a lot of those as examples for your homework, is because oftentimes it's very difficult for you guys to understand if I give multiple examples and make you do homework all by yourself. So remember when we first started talking about chapter 3 with logarithms and exponentials, I said that these were the most widely used mathematical concepts in our curriculum. And it's because so often it all revolves around exponential functions. The rate at which chemicals leave our body are what we're talking about when we're talking about isotopes or decay. Population rise and population death rate is a lot of things that we talk about using logarithms and exponentials. So the very first thing that we're going to talk about today is going to be the continuous compounding interest formula, which is A is equal to PERT. Now we've used this one before. Again, I need your brain to understand that E is a number, 2.718. A is still your balance, P is still your principal, R is your rate, but it has to change into a decimal, and T is still time. So nothing has changed with this actual formula and what we've been doing, but what's important is for your brain to understand that E is a number, okay? So now let's say I am wanting to invest a sum of money. My sum of money that I want to invest is going to be, it doesn't really matter, $2,000, $5,000. What your goal is you want to double your money or triple your money, because that's exactly what all of us want to do with our money at all times. So I'm going to be using the formula A is equal to PERT. And whenever I have A is equal to PERT, if I want to double my money, that means A now changes to twice the principal. So I'm going to have 2P is equal to PERT, okay? Now, if I solve this for T, for time, how long it's going to take to double my money, the P's cancel out, and I have 2 is equal to ERT. Now, remember, I have to get my exponents out of the exponent position. So the way I'm going to do that is I have to take the natural log of both sides. So if I take the natural log of both sides, the natural log and the E cancel out. So I have the natural log of 2 is equal to RT. Then if I divide by my rate, I can find the time that it's going to take to double my money. Okay? Now, the same exact philosophy can be used if I want to triple my money. But instead of 2P equaling PERT, I'm now going to have 3P is equal to PERT. Okay, the P's cancel out, so 3 is equal to ERT. Then I'm going to go ahead and take the natural log of both sides to eliminate the variables in the exponent position. The ln and the e cancel out, so I have the natural log of 3 is equal to RT. And again, I want to know how long it's going to take to double my money, so I'm going to divide by my rate. So I have the natural log of 3 divided by my rate is equal to the time it will take to triple my money. Now, this is super important for your brain to understand, because it doesn't have to be 2P or 3P. If I wanted to quadruple my money, it would be 4P is equal to PERT. So therefore, 4 is equal to ERT. If I wanted to have it 10 times that amount, I'd have 10 is equal to ERT. So these formulas can change with whatever you are wanting to do. So here we go. Let's go ahead and start one of the examples on your homework for tonight. I'm telling you that my initial investment is going to be $20,000 at a rate of 10.5%. I want to know how long it's going to take to double it, and I also want to know how much money I'm going to have in my account after 10 years. Okay? So the very easy one to do is always going to be this last column. That last column is pretty easy to do for the simple fact that you already know what the rate is going to be, you already know what the principal is going to be, and then you already know what the time is going to be. So if we go ahead and we write down A is equal to PERT, and again, in the directions on your homework, let me read those to make sure that you are fully aware. It says, complete the table for a savings account in which interest is compounded continuously. Compounded continuously means you have to use the PERT formula. So if you have to use the PERT formula, we want to know how much money I'm going to have in my account after 10 years. So that means I'm solving for A. So I know I have $20,000. E raised to the interest rate is now going to be 0.105. And I'm going to have that in my account for 10 years. So what I'm going to do is I'm going to come over, I'm going to grab my calculator, and I'm going to get a brand new document so that you guys can see this a little bit better. And I want a calculator page, and I'm going to simply type $20,000 and then I'm going to grab my E, raise the 0.105 because that's my interest rate times 10. And that means if I arrow up one time, I can grab the whole decimal. So that's $57,153.02. So that's how much I'm going to have in my account. $57,153.02. That's how much I will have in my account after 10 years. Okay, so now I want to know how long it's going to take to double my money. Well, to double my money, then that means I need to have 2P wrote the wrong thing there. So let's go ahead and delete that. So I'm going to have 2P is equal to PERT. The P's cancel out, so I have 2 is equal to ERT. Then I'm going to have the natural log of 2 is equal to my rate and my time. Well, here's where you're going to substitute in your rate. You know what your rate is. You know that your rate is going to be 0.105 times t. So now all you're going to do is you're going to simply divide by 0.105. And as you guys can tell, I'm not at school, so this is a little bit harder for me to write on, so just bear with me if it's harder to read. I'm so sorry. So we're going to come over to our calculator, and we're going to type that in. And that's going to be the natural log. And it doesn't like me, so sorry. The natural log of 2 divided by 0.105. And basically what that means is it's going to take 6.6 years to double my money. Okay? So number 3, after 10 years, I'm going to have $57,000 in my account. And after 6.6 years, I'm going to have over $40,000 in my account. And that's going to take 6 years to double it at least. Okay? So that is pretty much how I want you guys to work on tonight's homework, which is going to be problems 1 through 8. Okay, that's how you're going to do problems 1 through 8. Now let's keep going. Doing number 2. This time I'm giving you the rate and the time it takes to double the amount that you have in your account after 10 years. So we're still using A is equal to PERT. Okay, we are going to say that we have $2,000 in our account. We have no idea how much we invested. We do know that it's a 0.2 interest rate, and we know we've been in it for 10 years. So what I need your brain to understand is this right here is all just a numerical number. So what you're going to do is divide by that number on both sides. And that's going to give you P. So we're going to come back over here to our calculator. We're going to type in 2,000 divided by 0.02 times 10. And hit enter. And you're going to get that you invested $10,000. You will have the initial investment. And hold on one second. Need to make sure I type that in right. Okay, I did not type that in right because I forgot to put my E. So it's $2,000, and I knew I was wrong because you can't have $10,000. Let me grab my E down here this time. Hopefully I can hit the right buttons. $1,637.46 is the correct amount. So sorry about that. I'm just hitting the wrong buttons. So let's go ahead and take this and delete that. And that's 1637.46 is the amount that you are investing at the original time. Okay, that is your principal. Now I want to know how long it's going to take my principal to double. Okay, so with that being said, I'm going to say that we have the natural log of 2 is equal divided by my rate is equal to my time. Can you skip all that work that we've done before? Absolutely, because I gave you the formula here and you should be able to apply it. Okay, so with that being said, I'm going to take the natural log of 2 and divide it by my rate, which is 0.2, and that's going to be the time it takes to double your money. So we're going to go ahead over here and have the natural log of 2 divided by 0.02 and hit enter, and it's going to take 34.7 years to double my money. And that's a terrible investment. Terrible, terrible investment. What I need your brains to understand is a 2% interest rate is basically what you get for your savings account or for your checking account. This is a terrible investment. This is not the way you're going to take care of your money. You want to only have your savings account or your checking account be just enough amount of money to be able to pay bills. The rest of it, you really, truly want to try to invest. Okay? Now, the next topic we're going to talk about is the isotope problems. And this is basically saying, okay, how much of a chemical, once you go and have dye put into your body, how much of that chemical is still left in your body after so many hours? So this formula looks very similar, very, very similar to the isotope problems, okay? Now, with that being said, you need to understand that Q of T is the balance or the amount of isotope left. C is the initial amount that they injected, and R is the rate that it is going to slowly decrease out of your body, and T is the time that it's going to take, okay? So again, just make sure that your brain is understanding that all of these are looking about the same. Q of T as A, C as P, E as E, R as R, and T as T. So let's go ahead and go into this. Half-life. Half-life is where basically you have half of the chemical left in your body. So this is the balance where the balance of the isotope is half of the original amount. So instead of doubling our money, we are taking and wanting to know when we're going to only have half of it. Okay, so 1/2 C is equal to cert. Okay, with that being said, the C's cancel out, so you have 1/2 is equal to ERT. Same exact philosophy, 1/2 is equal to RT. So 1/2, natural log of 1/2 times R is equal to T. So everything is still the same concept here. So I'm giving you the isotope, the half-life, the initial quantity, and the amount after 1,000 years. This column, the first column, is not necessary for you to be able to do this information, to be able to do this problem. It's just there to kind of jack with your head and confuse you. So the first entire column is not necessary. It's just talking about the isotope that we're dealing with. However, the half-life is kind of like the time to double. So half the life is going to be 1,600, and the initial quantity was 10. And then the amount after 1,000 years was going to be questionable. Okay, so looking at this problem, we know that the first column is not necessary. The second column is the half-life. The third column is the initial quantity. And the fourth column is going to be the amount after 1,000 years. In order for us to do the last column, which is the amount after 1,000 years, I have to know the rate at which this thing is decaying or exiting, okay? Which means I have to deal with column 1 first, or column 2 first. So I'm having that half-life formula, okay? The C's cancel out. And so I have the natural log of 1/2 over R is equal to T. That's what we've been using, okay? But I know what the time is. What I don't know is what the R is. So basically what you want to do is you want to swap these two letters. So you're going to have your time down here, and that's going to be equal to your rate. So with that being said, I have the natural log of 1/2 over 1,600 years is going to be equal to the rate. So if I come over to my calculator and I type that in, I'm going to have the natural log of 1/2 divided by 1,600. And I'm going to hit enter. Now you get this really, really, really long decimal. I'm going to arrow up one time. I'm going to get this really long decimal. So for our purposes, you're going to say that it is a negative rate, meaning it's declining and decreasing. So it's negative 0.30 and then 433. That's the rate at which this isotope is declining or decreasing, okay? So now I need to go ahead, I need to find how much I'm going to have after 1,000 years. And I'm going to use that rate. So I'm going to have my Q of T, which is the amount I'm going to have, is equal to cert. Okay, so I want to know how much I'm going to have, so I'm going to go ahead and say I had 10 grams initially. E, my rate is negative 0.000433 times 1,000. Okay, so I'm going to come over to my calculator and type that in, 10, and then I'm going to grab my E. I'm going to arrow up twice and get that rate times 1,000 and hit enter. What this means is after 1,000 years, if I have 10 initial grams, I'm going to have after 1,000 years 6.48 grams left. Okay? So let's go ahead and do a problem. I'm going to go ahead and do problem number 9 with you. And number 9, again, I don't need these two columns. It's not important. I want to know how much I'm going to have after 1,000 years. So for number 9, I need to first go ahead and find my rate. So my rate is going to be found by going ahead and saying, I'm going to have 1/2 the natural log of that divided by my years, 5730, and that's going to be equal to my rate. So I'm going to come over here and take the natural log of that. 0.5 divided by 5730 and hit enter. And I did not type that in right. So my rate at which it's declining is negative 0.000121. Okay, so now I need to go ahead and find the amount that I'm going to have after 10,000 years, or after 1,000 years, sorry. So I'm going to have Q of T is equal to cert. The initial amount was going to be 3 grams. My rate is negative 0.000121 times 1,000. So come over here, 3, grab my e to the x. I'm going to arrow up and grab this decimal. I'm going to multiply that by 1,000. So my amount that I'm going to have after 1,000 years is 2.66 grams. Okay. Now you guys are going to go ahead and do the number 10 by yourself. Okay. Now that brings us to the next part. And this is population prediction. And this is actually number 11 on your homework. The population P in thousands of Bellevue, Washington is given by P equals 110 e to the KT, where T equals 0 represents the year 2000. So super important. T equals 0 represents 2000. Okay. Now, with that being said, it says in 1980, the population was 74,000. Okay. Find the value of K and use the result to predict the population in 2020. Okay. Now, that means if T is equal to 20, that's going to be 2020. Which means, what is going to be 1980? Well, what you should have gotten is that that's going to be negative 20. That is the correct amount. Okay? Now, what we're going to do is we're going to simply use our formula. Our formula that we're talking about is going to be having to find our interest. We have to find our interest rate, because this is what it looks like. It looks like PERT, doesn't it? We need to find what our rate of decline or increase is going to be. Okay? Obviously, we're inclining. The reason why we're increasing is because the population in 1980 was 74,000. But now the population in 2000 is going to be what? Well, your brain should look at this and say, okay, well, that's going to be 110,000. Now, find the K and the result to predict the population in the year 2020. So what I need your brain to understand and grasp is that we have ordered pairs. The ordered pairs that we have are going to be 0 and then 110. And then we also have the ordered pair negative 20 and then 74,000. Okay? Now, we also need your brain to understand that this is in thousand, which is why you are just going to make that 74 and not 74,000. Okay? Now, what we're going to do is we're going to find our K value. So how do we go about that? We are going to simply do a plug and chug here. We know that using this formula, P is equal to 110 e to the KT. My population was 74, 110 e. The rate I don't know, but that was time at negative 20. So I'm going to have 74 divided by 110 is equal to e to the k to the negative 20. So now I'm going to take the natural log of this, and that's just a number, equals negative 20k. And then I'm going to take that value and divide it by -20. And that's going to be equal to your rate. So if I come over here to my graphing calculator, I'm going to take the natural log of 74 divided by 110, and then I'm going to divide that by -20. And you're going to get an interest rate or a decay rate or a growth rate. In this case, it's positive, so therefore it's a growth rate of 0.019821. So I'm going to come back over here, I'm going to write that down. 0.019821 is equal to your K. Okay? Now we're going to use that information and we're going to actually do a prediction, because our formula now is going to be P is equal to 110 e to the kt. That is our original formula. I want to find the population. My K is going to be 0.19821, and I want for the year 20. Why? Because that's 2020. All of that is just a number, so I'm simply going to go and plug that number in. So that's going to be 110 e to the, I'm going to arrow up and grab that decimal, and then times 20. So my population is going to be 163.514. What this means is 163,514 is my population in 2020. Okay? So that's what you would have. Next, we're going to be talking about earthquakes. Earthquakes and the intensity of them. R is equal to the magnitude, the log base 10 of I over I sub 0. I sub 0 is equal to 1 is the minimum intensity. That is the minimum that you can use, okay? I is the intensity of the earthquake. In other words, how far out it's going to go. All this is a simple plug and chug of this formula. So if we're doing number 15 on tonight's homework, and number 15 is very simply saying the Fiji Islands had a earthquake in 2003, and the Richter scale magnitude was 6.5. So if I'm using my formula, R is equal to log base 10 of I over I sub 0. That means you're going to plug in the 6.5, log base 10. I is what we don't know. I sub 0 is always going to be 1. So if I write this as an exponential, I'm going to have 10 raised to the 6.5 is equal to I, and that's going to give your intensity. So if I come over to my calculator, that is going to be 10 raised to the, and I actually have a button for this, so I'll show you that button right here, 10 to the 6.5, and this is what you get. So if I arrow over to the right, you are going to have intensity of 3,162,277. That is the intensity of this. So 3,162,277 is the intensity of this earthquake. Okay. Number 16, I give you the opposite of this. So this is going to be R is equal to log base 10 of I over I sub 0. This time they're giving you the intensity, and they want you to find the other, the magnitude. So they give you 39,811,000 divided by 1. So all you have to basically do is put this into the calculator, and I'm going to hit log base 10 of, grab that number again, 39,811,000, and hit enter. So the Richter scale was 7.6. That is me doing your homework tonight, getting you started. Please make sure that you are looking at your section of your homework in your textbook, reading through that and understanding a little bit better. It'll help you tremendously. If you look at number 12 on tonight's homework, I've pretty much gone through problems 1 through 10 for you. Problem 11 I did for you in class. Problem number 12, they want you to give the linear model and they want you to give the slope and translate that and then compare and contrast. Number 13, it's also in your textbook. And number 14. Number 14, window size. Let's talk about that. Your window size. I want you to be at a domain going from 70 to 115. And your range, I want you to go from 0.002 to 0.033. That is where you are going to find this graph at the easiest, okay? So use that as your window size. And that should be all that you have for questions on tonight's homework. Okay?